Hello, today I'm going to show you how to use the mousearm repository that we developed on GitHub. So I linked the address in the description of the video, and you can just go to that. And you can see that in this repository we have a README file that you can read through. Let's start from the usage instructions. So I created an example walkthrough that we can go through. But first, let me show you how to go through the demo, which we can do in just a few minutes. So navigate to the link and follow the instructions there to download Anaconda. It will have you do things like enter your email address and it will send you a quick confirmation code, but it's completely free and you can download that. Once you sign in, you will see this screen where you can choose your download based on your operating system. I'm on Windows, so I will download the Windows one. It will start downloading that here. It's around 1 GB, so if you're on a slow network, it may take a couple of minutes to complete. Once it's done, you can double click on the file to open it. You can see it's loading the setup and verifying the installer. This may take a few minutes. When it's done, you will encounter this, which you can just click through. I already have it installed, so I'm going to quit out of this, but it should be pretty straightforward to get it fully installed from here. Now we can go back to the GitHub page and we will create a new Conda environment. To do this, you can start by going to your application searcher, Launchpad on a Mac, or the Windows button on Linux or Windows, and you are just going to type Anaconda. Then, this is important, make sure you click on the Run as Administrator. So right click and Run as Administrator or click this button. Once it's opened, you will see a window like this on your screen. You can resize it to however you want. You can also change the size to a size that suits you. I'm going to make this a bit bigger. And you should see something at the beginning that says base. This is telling you the environment that we are in within Anaconda. Currently, we're in the base environment. You may also notice it says C:/Windows/System32. That is not important to us right now as we will just be creating the Anaconda installation. To do this, type the command on screen and then hit enter. It will go through. Don't worry if you see any errors, they're typically not fatal unless it stops the application from running. What it's doing now is creating a new Anaconda environment that you can install Python packages in without messing up your default Python installation. And then note what it says here. It says to activate this environment, use this command. I also put that in the GitHub. So now just activate the environment. You should see that you now have mousearm-test in the parentheses on the left, and that means that you have successfully activated the environment. Now you're going to install OpenSim via Conda. OpenSim is a graphical application that allows us to view the results, but it also has some important biomechanical backends that we will be using. To do that, type the command on screen. When it pops up with this menu, just hit Y and enter. This may take a few minutes. When it is done, you will see something like this, saying that it's done. Next, you are going to go into your Documents folder. So on Linux or Mac, this is easy. You just do what's on screen. For Windows, it is as well, except you need to replace the user profile thing with your user profile. If you don't know your user profile, you can just type echo %user profile in all caps. and another %, and hit enter. It will tell you your user profile. So now you can go to cd and type in that path. And then put \documents. Now you can see this has changed to reflect that you are in your documents folder. I'm going to clear the screen because it's getting a little bit messy. And now you're going to clone this Git repo and install the library. So there are two ways of doing this. The first is using SSH, which is used on most Linux and Mac systems. I believe they're phasing out support for HTTPS. Or you can use HTTPS, which is what I'll be using on Windows. So you can type in git clone. And also, if you don't have Git, you can go to gitforwindows.org and hit download. It's pretty simple. And then you will have Git installed. So anyways, you type git clone and then the name of the repo. So if you're navigator to it, you can just copy this thing up to the mouse arm and do Control V to paste, and then make sure you put another / and then make sure you put in a .git, and then hit enter. You will see it will say cloning. Let that run through. It should finish pretty quickly. You can see mine finished here. And then you're going to go into that directory. And to do that, on Windows, Mac, and Linux, you just type in cd space mousearm. And now you can see it is now inside of the mousearm folder. So now you're going to type in pip install uv. And if this errors out, that means that you don't have Python installed. You can install that through just Google Python. And it will show up here. Go to the downloads page. And you can download any of the versions here. I suggest you download 3.11 for this one. Now, once this command runs through successfully, we are going to use this library called uv to install the mousearm repository. So you can just type uv space pip space install -e space dot. Put that on the screen and hit enter. You will see it will start to install version 0.1.0 and also some other dependency libraries if you don't already have them installed. Now you can see it's completely done. It said it installed all the packages. And now we can move on to the next step, which is the demo. So now you are just going to type in the command on screen, cd mousearm /demo. And then you can type in python demo.py. If it runs successfully, you will see it will start spewing out this information. And this will take a few hours to run, especially if you don't have a GPU. But that's just to show you how it works and to confirm that it can run before you run any of your own experiments. So you can just do Control-C or Command-C if you're on a Mac to exit out of this. And now I will show you a sample usage case with your own data. So you can see here I've just pulled up the folder that has the data in it. I can go into that and you can see I have a reachset_1 and reachset_2 folders. Inside of each of them, there is a lot of excess information, but the only one that you really need is the kinematics_1.csv. Make sure you title it this for each one that you put in their own reach set. We can go ahead and look inside of that file. And you can see that the data is arranged in this form, where time is the first column, and then we have the X, Y, and Z positions of the paw, wrist, shoulder, and elbow in that order. you will need to go ahead and make sure that your data are arranged in this way after you export them from Deep Lab Cut. Now I'm going to show you how to visualize the output of the model, including the motion paths and the muscle activations. We will do this through this tool called OpenSim Creator. You can download it from their website. It's a free community developed open source tool that's used for making models in OpenSim, but we can also use it to visualize our model. So I can open that up here. When it starts, you'll see a screen that looks like this. You can go ahead and click on the Open Model button. It'll pop up a search thing, and if you go into your Documents folder, then into your mouse arm that we just made, into the mouse arm inside of that, you will see this file called model_to_scale.osim. So we're going to double click on that to open it. And you can see it here. Right now it just looks like a few balls with a bunch of spikes coming out of them. You can fix that by going up to this number over here. It says 1.00 and change it to something like 0.01 or 0.04, let's say. So now you can see this is the model of the mouse. You can see all of the muscles and the bones, and also the joint markers. Now to load the motion file, we will go to File, Load Motion. And I'm going to go to one of them that has already run, just so I can show it to you better. And here's one of the outputs that comes from it. We'll have a bunch of them called muscle solution adjusted underscore kinematics 1 down for however many you had in that reach set. We're just going to open up 1 for now. You can see it's very small, so we will zoom back in to look at it. And now you can click play up here to visualize it. This one's a pretty short one, so it runs through pretty fast. But you can also slow it down here with this speed number. Let's say we want it at 0.2 speed. And we can visualize it like that. And also do note that the muscles are red when they are activating and blue/purple when they are not activating. So you can see that they also change color in relation to the values that the tool predicted. So now I'm going to show you guys how to process the output files from this model. So the output files will look like raw data files. They will be .sto, which is just the .storage file for OpenSim. And they'll also give you CSV files for the muscle kinematics. And I'm going to show you today how you can process those. First, go to the directory where you have your .sto files. And then you're going to go to the file, right click on the file that you want. In that case, I want to analyze this one. So I'm going to right click, and then you're going to do copy as path. And now we're going to use this later. This just stores it on your clipboard. So now go to your Anaconda terminal from earlier. I gotta move around the directories a little bit. Okay, and now you're going to use this thing called IPython. So if you don't have it, you can get it by running pip install IPython. It's going to tell me I already have it and such. But basically this allows you to run Python things line by line in your terminal, which is really, really helpful. Then also make sure you have pandas installed. So pip install pandas. And then also matplotlib. So pip install matplotlib. And we're going to use all of those. So first type in IPython and just hit enter. It should launch up your IPython terminal if you have this installed. And in here we're going to type in some commands to import that. So basically we're just going to do import pandas as PD. And then from the GitHub, you can see we're right about here. you're going to copy this mcol names, and this is basically just every single column name for our model, and that will allow it to import them. So you can see it's pretty huge. Just hit enter. It should run through. And then the next one is this file. We're setting the file. So you can just type file equals r quote. I'm going to go back and copy the path. So recopy the path. And you're going to do file equals r apostrophe. And then you're going to paste that path. Looks like it added an extra apostrophe for some reason. I don't know why. And then just hit enter. Nothing should happen. It should just go to the next line. If it errors out, you probably typed it wrong. And then next, we're going to go in and analyze our muscle solution. So we can import that by just doing muscle solution equals this whole thing. This is also in the GitHub right here. Hit enter. Nothing should happen. It is currently just imported it, and now it's available for us to use. So now you can run print muscle solution.columns, and this will give you a list of your columns. You can see there's a big whole list here. Let's say I want to plot maybe the biceps. So we're going to go in here, Control C to copy that. And then now we're going to use matplotlib. So just do import matplotlib.pyplot as plt. And then we're going to do plt.plot muscle solution of column time, comma, muscle solution of quote, and then you're going to paste that thing that you copied earlier that you want to analyze. In this case, it's the biceps long head, and it should tell you have an output, but you shouldn't see a plot yet because you haven't shown it. I'm going to go ahead and add in some X and Y axes labels so we can see those properly. And then we can just do plt.show in double parentheses, and this will show our plot. You can see it here. We now have our plot. It looks really nice. And this is for the biceps long head. You can go ahead and repeat that for pretty much anything or use other ways to analyze that data. And then also you can use this to get data on your muscle fiber lengths. So let me show you here inside of the GitHub. If you go into the mousearm directory inside of it, there's this getmusclelengths.py file. And inside of here, you can see there's these paths that you have to change on your own to your own path. But then after that, you can run this script, and it will give you more output files up here, like these analyze muscle analysis. In this case, we're going to be looking at the length one. So you can pretty much do the same thing as earlier with your import pandas. And then this time there's a new column names. That one's also in the GitHub here. You can just paste that in. That'll reset that variable. And then for your file, you can go ahead and right-click copy as path again. Once you get these, you should just be able to paste that in there. And then copy in your muscle solution line. And then you can list the columns again to get a list of the columns if you want to plot them. Let's say I want to do the biceps long head again. I can go ahead, we don't need to re-import matplotlib, but we can do our plt.plot. And then you can go ahead and put in your biceps long head, or any other one if you'd like. And then we can go ahead and add in our X labels and Y labels. And then plot it with plt.show. And then this is our biceps long head fiber length over the course of the movement. So these can be really useful tools for analyzing that data. You can pretty much do anything once they're imported into the Python pandas data frames. You can do pretty much anything you want with the data. from there. So yeah, that's about it. If you have any questions, you can feel free to post them in the forum or in the comments below. And thank you for watching.